Or after 4 and back, All right, Chapter 7, starting to get back into the mathematics stuff for the next 3 chapters. Wow, for the rest of the year for the most part. So 7.1, we're going to talk about this thing called the mole that you've been seeing here and there. Now we're going to have to know what it is. So representative particles. This first slide is easy stuff that you kind of know already, but it is very, very important that we're all on the same page here. So you have to know what a representative particle is or what that means. And all that means is that you're talking about the smallest piece of whatever kind of substance it is that you're dealing with. Okay, so the smallest piece of whatever it is that you're dealing with. So what's the smallest piece of a molecular compound? No, not an atom. Molecule, where it's still that compound. Or an ionic compound would be a what? So that's what we're talking about. So if you forgot, you want to get it down again. Smallest piece of a molecular compound, that's where you're talking about covalent bonding. Remember, non-metal bonded to non-metal, sharing electrons. That's a molecule. You said the other one, an ionic compound. Smallest unit would be a formula unit. So that's where you usually have a metal and a non-metal, but for sure a cation bonded to an anion. And then the last thing that you'll probably run into is, what if you're talking about some element, like a big chunk of copper? What's the smallest piece of an element? An atom. Okay. So that's what we're talking about in terms of smallest particle or representative unit. What can represent the whole thing? Okay. So now we have this term moles or mole. We're going to abbreviate it probably pretty much from this point on, or at least when we're doing the mathematics. We're going to abbreviate it MOL. And you think, it's just getting rid of a letter or 2 letters. What the heck's the big deal? When you're writing this all the time, it makes it a lot easier or quicker to write MOL. You might have to write that 3 times. This one problem. It's minor, but it does help. So what is the mole by definition? Here's the definition. This is probably a multiple choice question. It is the number of carbon atoms in exactly 12 grams of carbon-12. And carbon-12 is just a particular isotope of carbon. Remember, there's also carbon-13, there's also carbon-14. We're talking about carbon-12 in particular. And you don't have to know why it's carbon that we deal with, because that's a long story in itself. We're just going to use it for what we need it for. So how many carbon atoms are exactly in 12 grams of carbon? That's like one little piece of charcoal that you would put in a charcoal grill. That's about 12 grams. 1 mole is this number. It's 6.02 times 10 to the 23rd particles. So particle could be whatever it is you're talking about. In this case, it would be atoms of carbon. Or it's called Avogadro's number. And I'm just going to add this. Sometimes people will call it N. So if they're doing a calculation, they'll put N in. And you just know that that's 6.02 times 10 to the 23rd. And some people will put that in memory in their calculators. They can just push M1 and that's known to be mole all the time. I don't do that. I just enter it. A big thing to remember, though, when you're entering a number like this in scientific notation, how do you enter times 10 again? It's that E button, or EE. So it would be 6.02 E23. So remember that. So why do we even use scientific notation? You think it's dumb or whatever a lot of times. Well, you could write it this way, or you could write it out every time in long form. So in long form, it would be this. So 602 with 21 zeros is what you'd have to write every time. And how long would it take to count that number? Say you had a mole of carbon, which is 12 grams of carbon, which is a little piece of charcoal. Couldn't count that number in your lifetime. It'd take many lifetimes to count that. So that's how big the number is. Why is the number so big? Because the atom is so what? So small. So that's why we're using this number. Don't write this down. It's just to get your brain thinking the right way. How many eggs are in a dozen? 12. Only donuts in a dozen. What if it's a baker's dozen? 13. How many flowers in a dozen? 12. So a dozen is just 12. It's just a number you know. The same thing, the mole. It's not a crazy number or anything. It's just this certain number. So how many eggs are in a mole?
6.02 times 10 to the 23rd.
Another thing to remember is that it's a really big number. So this exponent is positive 23. I've seen people put negative 23 and then just go off on a tangent. How many sheets of paper in a mole, Mills?
6.02 times 10 to the 23.
How many pencils in a mole?
Same thing.
Same thing. It's just a number. Okay? So don't be afraid of that. Bakers don't use math. So an example here. I get this one in your notes. So the example is a calculation. Start using our calculators again here. Periodic tables. And maybe not in this one yet, but how many molecules, and I shorten this up so you don't have to write as much, but it probably would say in a problem, how many molecules of CO2 are there in 4.56 moles of CO2? Remember, you can write mole just MOL. And it's probably going to come up when I write molecule. Don't write MOL because that's mole. You can write MOLEC, and that's good enough for molecule then. So to do this problem, back to dimensional analysis. How do you start this problem? What do you always start with? The what? The given. Start with the given. Here's the given. There's 4.56 moles of CO2. So we're going to start with that. So write it down. And this is another thing, like the last chapter, naming. Each day is another little step, and it just keeps building and building and building. Actually, for the next month, every day is another little step. You miss one of those little steps, and it kind of starts to throw things off. So make sure you're keeping up. And if you get behind, come see me. So that's what you start with. And then you multiply by what? I have no clue. It doesn't matter. What are we trying to go to anyways? What's the how much, how many? Molecules, identify that. So I'm just going to put question mark above that. Our last unit should be molecule. So with that in mind, how are we going to get to molecule? Answer is who cares? Did that before. All I know is we don't want the mole as our answer. So I want to get rid of this. How do you get rid of it? Put it on the bottom so that it will cancel out. So we go moles of CO2 to something on top. Well, what can we go to? Can we go to a molecule? If you're not sure about something, just write it down. You can always erase it. Okay? So what you have to say is there a relationship between these. So first of all, CO2, is it a molecule? Yeah, because it's a nonmetal and a nonmetal. So nonmetal is a molecule. So these two are, this will work. And you can go from the mole to just about anything. And you can go from anything back to the mole. So I'm going to start saying Monday probably, go for the mole. If you're stuck, just try using the mole and see where you end up. So now the question is, which one's bigger, a mole or a molecule? A mole by far. That's going to be the biggest thing that you're ever going to deal with probably in terms of number or quantity. So what do I put with the mole? 1. How many molecules of CO2 go into 1 mole of CO2? Avogadro's number. Avogadro's. So mole of CO2 divided by mole of CO2 cancels that out. If we were to solve right now, what would the unit be? Molecules of CO2. And that's what we want. So we're done. We're done setting it up. So what you do in your calculator, 4.56 times 6.02 times 10 is what I'm trying to box out there. Remember, that's E. So give that a shot, as simple as it is. Always try these on your own. So I always see people trying it on the quiz then and not having a clue how to enter it into their own calculator. So you should be getting 2.7451, something like that. Everybody get that? Yep. And then on the end of the screen, a little ways, it says E24. Always look towards that end. Make sure that there is or there isn't something there. That E means what again? Times 10, in this case, to the 24th. And we need sig figs anyways. So how many sig figs in 6.02? 3. And the number we started with, 4.56? 3. So we can have 3 in our answer. So just put one line through what you write down. And we're going to say 2.75. Times 10 to the 24th. Units. Otherwise there'd be one wrong. What's the unit? Right there. Molecules of CO2. And then box out the final answer and you're done. So moving on. That one's pretty simple. They get more challenging. They are going to get more challenging with this one right here. So how many atoms of carbon are in 1.23 moles C6H12O6, which is glucose, which is blood sugar, which is flowing through your blood right now? If it wasn't, you'd be dead. Well, how many atoms carbon? And this problem is going to be an example of where knowing what the different representative particles are comes into play. Otherwise, you can really screw this one up. What do you start with in this problem? That many moles, that's your given. So 1.23 mole. Whoops, pen's going haywire here. So 1.23 mole of C6H12O6, and get in the habit of writing down what it is you're working with, because we're going to be going from one thing to another, and it's going to get real messed up here sooner than later. So just get in the habit of always writing it down, the units and everything. So I don't want moles of C6H12O6, so what do? Put it on the bottom. I'm going to go mole of C6H12O6. And what can you go to? Can you go to atoms? Think about this, possibly. Is C6H12O6 an atom? Then we can't go to atoms yet. C6H12O6 is a what? Molecule, because it's all non-metal. So we can go to molecules of C6H12O6. What's bigger, a mole or a molecule? A mole, put a 1 with it. How many molecules are in 1 mole? Avogadro's number, 6.02 times 10 to the 23rd. What should I do right now before I move on? Cancel out units that can be canceled. So mole of C6H12, and I'm never canceling the numbers out, just the unit. So is molecule what we want? So we got to keep going. And again, how many steps? However many it takes. So we don't want molecule of C6H12O6, so put that on the bottom here. C6H12O6, right? Now, what can we go to? Are there atoms in a molecule? Yes. Are there atoms of carbon in the molecule? Yes. So now we can say atoms of carbon. What's bigger, an atom of carbon or a molecule of C6H12O6? Molecule. So we'll say 1. Now what this is saying is in 1 molecule of C6H12O6, how many atoms of carbon are there? 6. So you put the 6 there. And molecules is 1. What's my next step? Solve it. So try that one. A few more things to type in, see what you get. So I'm getting 4.44276 times 10 to the 24th. Anybody else? Yep. Okay. So you should be getting that. Make sure you are. How many sig figs can you have in this? Well, how many are in this 6 atoms here? It's infinite. 1 molecule, that's saying in exactly 1 molecule, it could be it's 1.0 forever. There are exactly 6 atoms. So this is infinite right here. Okay. This 1 right here, do you need it here even? If that wasn't there, does it matter? No. So there's 3 in 6.02, 3 in 1.23, so you can have 3 in your answer. So that's going to be 4.44 times 10 to the 24th. What else do I need? Atoms of carbon. So atoms, carbon. Box it out, done. So now the periodic table we're going to get into and using this. If you look on your periodic table, for example, oxygen. Find oxygen on your table. What's the atomic number for oxygen? 8. So there's the atomic number 8. Just in case you want to add something or you think you're going to forget it. That's the atomic number. What's the atomic number mean? No. Just protons. Okay. So atomic number is just protons. Let's go from up here. So what the heck is this number on the bottom then? It's not the mass number. It's the atomic mass or the molar mass or the molecular weight or the atomic weight or the gram formula mass. There's all kinds of names for it. Okay? And that is basically the number of grams. It's coming down in the notes here. That's how many grams it would take to have 1 mole. So if you wanted 1 mole of carbon, which would be 6.02 times 10 to the 23rd atoms of carbon, how much carbon would you have to mass out in the lab? 12.011 grams. Okay? So that's what that number is. So these 4 terms on the board right there, gram atomic mass, gram formula mass, molar mass, atomic weight, molecular weight, there's all kinds of different terms that you could have. They're all the same. They all mean the same thing. And on your periodic table, that's that number below the element. On the periodic table on the wall, it's the number below the element, or on the upper right actually in red. So those mean all the same thing. I use molar mass usually is how I say it. At Tech they said atomic weight. Never heard it called gram atomic mass or gram formula mass by anybody else other than a textbook. So with that said, so you can hopefully understand what it means when you look back at your notes if you're lost a little bit. If I take carbon, for example, at this next note here, if you needed 1 mole of carbon, or 2.5 moles, whatever it is, but 1 mole of carbon, that would mean you would have to have 12.011 grams of carbon. Or that would be, in that sample of carbon, there would be 6.02 times 10 to the 23rd atoms. Okay? What if it were oxygen? How much oxygen would you need for a mole? 16, looking at your periodic table. So 1 mole of oxygen is 16 grams of oxygen, as long as it's just O, not oxygen gas. Or it'd be 6.02 times 10 to the 23rd atoms. What if it were CO2? What's it say for CO2 on your periodic table? It doesn't. So what do you do there? Add them up, whatever you need. You just put the puzzle pieces together. So if it were 1 mole of CO2 that was being talked about, that would be 44.011 grams of CO2, which is the mass of 1 carbon, 12.011, plus 2 oxygens, which is 16 times 2, which comes to that number. Or you'd have 6.02 times 10 to the 23rd molecules of CO2, or a mole of CO2. Okay? So we're going to start using that a lot now. We're going to use it in the lab a lot. We'll be in the lab on Tuesday. It's looking like already. After a couple of weeks of not being able to get in there. So an example now, using some of this molar mass stuff for atomic weight, or whatever it's going to be called. This time it's called gram atomic mass. So just a simple question, good multiple choice. What's the gram atomic mass of sodium? 22.99, Na on the periodic table. So 22 point... Your table, it says 99? Yep. 99. Except it needs a unit. What's the unit? AMU. It's AMU if you're talking about just atomic mass. But we're talking more molar mass here. Okay. So the unit is, it's how many grams there are in what? 1, not atom. Not molecule, mole. So it's grams per mole, which is how many molecules or atoms or whatever you're talking about. 6.02 times 10 to the 23rd. One that's not that much more difficult. What's the gram formula mass of CH4? So this one, it'd be 1 carbon. So when I enter these in your calculator, I see people adding up all the different elements, writing the numbers down, and writing the 3 or 4 or 5 or 2 numbers down. This is just going to be 12.011, that's from the periodic table, plus 4 times 1.00794 from the periodic table. Equals. That's how you enter them in your calculator, no matter how many there are. Okay? So just try that real quick, as simple as it is in your own calculator. So that you're not lost when we get to a quiz. Lots of mini quizzes in this chapter too, so be aware of that. Probably not one Monday, but probably one Tuesday on this stuff. So this is coming out to 16.04276. And then you just keep everything. That's what you would use in a math problem. And the unit, remember, is grams per mole. Okay? So that one's pretty easy.
So no sig figs on these?
No sig figs. You keep everything. And then you plug everything into the equation that you're writing. So now what's the molar mass of oxygen gas? This could be tricky. Well, what is oxygen gas? O2, it's a diatomic molecule. So O2 is 2 oxygens, so it's 2 times oxygen is 16.00. So it's 32.00 grams per mole. I get asked every year, I got a first hour, how do you remember all of these? You're just using them all the time. You're going to remember, I guarantee in a week you're going to know nitrogens, hydrogens, oxygens, carbon, probably without even having to look at the periodic table much, just because you're going to use it so much. So what's the atomic weight of calcium nitrate? Well, first you have to figure out the formula for calcium nitrate. So this is where Chapter 6 is coming back into play now. So what is calcium nitrate? You can't just think and write it down. Some people can. You have to figure it out. First of all, calcium is what kind of element? Metal. Bonded to nitrate, which is a what? Polyatomic ion consisting of all nonmetals. Metal to nonmetal is what kind of compound? Ionic. Boom, you should start thinking charges. You need charges to figure out the compound. So calcium is Ca with what charge? 2 plus from the periodic table. Nitrate you should have memorized. NO3, 1 minus. So you got a 2 plus and a 1 minus. How many nitrates do you need to balance out the 2 plus? 2. Or you could say I'm going to take the 1, cross it to here, I'm going to take the 2 and cross it to there. So that the formula is Ca1, NO3 in parentheses because I need 2 of them. Okay. And then for in your calculator, instead of 1 Ca, that's whatever it is, I don't have that one memorized, plus 2 nitrogens, write that down, plus 6 oxygens, write that down. We can do it all at once. So what's calcium's molar mass? 40 or something like that? 40.08, so it's going to be 40.08 plus, how many nitrogens are there? 2 times 14.00 on your table, I think? 007. Plus, how many oxygens? 6 times 16.00. Just 2 zeros, I know, on yours. Equals, and enter it. So you can always get a molar mass in one operation on your calculator. What does this come out to be? 68 plus 48, something like that. What do you got? 164.094. Anybody else got that? Yeah. All right, we'll call it good then. How many sig figs should I have in this? All of it. It is what it is. What's the unit? Grams per mole. So the molar mass calcium nitrate is 164.094. So if you wanted 1 mole of calcium nitrate, how many grams would you have to measure out? That many. How many formula units would you have if you had that many grams? 6.02 times 10 to the 23rd. So those are all little multiple choice questions I'll probably ask. So an example now using this stuff a bit. What is the mass of 2.34 moles of carbon? It's the mass of 1 mole of carbon. No, that's how many. Where do you get it from? Periodic table. Mass of 1 mole is 12, so how are you going to figure out the mass of 2.34 moles? Multiply them, or let's say it's a test and your brain is just thinking straight dimensional analysis. You start figuring out it's going to be 2.34 moles of carbon to start with, times, and you say, okay, I don't want moles, put it on the bottom. Can you go to mass? What is mass? Grams. Are moles and grams related? Grams per mole is the molar mass of something, and they could be switched. Doesn't have to be grams over moles. It can be switched upside down. If this were grams to start with, it could be switched. What's bigger, a mole or a gram? Mole. How many grams in a mole of carbon? Periodic table says 12.011. So So moles of carbon are gone, and then you multiply those two numbers. So multiply those two numbers, see what you get. Did you get Mills?
28.10574.
Anybody else? Same thing. How many sig figs can you have? 3. This is a calculation now, so we have to bring it down to 3 sig figs here. So it's 28.1. Unit? Grams of what? Carbon. So you always put unit and what it is you're talking about. So that many grams of carbon. Next example. How many moles of Mg, which is magnesium, is 24.31 grams of Mg? Actually call this 24.30. Forgot to change that. So how many moles of Mg is 24.30 grams of Mg? And this one, nobody should get it wrong. But a lot of people do get these wrong. So they don't make sure they have a good clue of what's going on before the next day comes and we move along. How would I start this problem? What do you start with? Given. That number. So we have 24.30 grams of magnesium times, I don't want grams, I want what? Here's what we're trying to get to, moles of magnesium. How do you get rid of grams? And on the bottom, grams to what? Moles. Who's bigger, a mole or a gram? How many grams of magnesium in 1 mole? No, not 6.02. That would be atoms per mole. This is mass. Where do you get this from always? Periodic table. And it's 24.30. Okay? Yeah, something with the light today in here. It's not working too good. So 24.30 from the periodic table. If you think you're going to forget later where that number comes from, you might want to do that. Just say that came from the periodic table if you're looking back in your notes. So grams cancels out. What's 24.30 times 1? 24.30. Divide by 24.30? 1. How many sig figs can you have in that answer? You should have 4. So how do you have this have 4 sig figs? 0.000. And you can measure that in our lab. We have balance that'll go that exact. Okay? And the unit is moles. Magnesium. And that's done. Any questions before we move on? Alright, these are baby steps. Monday's going to be bigger steps, and then Tuesday's going to be lab, and Wednesday's really going to be some big steps. Alright, don't write this down. Just think about this a bit. So how big of a container would it take just to try to understand how big the mole is? Contain 1 mole of rice grains, or how small? So the rice grain, is that big or small? Pretty small. So how big of a container do you think it would take to contain 1 mole of rice grains? How many rice grains in a mole? 6.02 times 10 to the 23rd. Count them out. How big of a container?
2-gallon bucket.
2-gallon bucket, that's pretty big.
50-gallon drum.
50-gallon drum, getting bigger.
Olympic size swimming pool.
Olympic size swimming pool is getting closer, I'll say that. How's a rice grain compared to the size of an atom? Huge, huge, huge. So somebody's figured this out. It would take a cube 120 miles on each edge. So from here to Marquette is about 120 miles. And then over that distance, and then up that distance is how big of a container you would need to get a mole of rice grain, contain a mole of rice grains. So it's huge. Okay.
Think it out somewhere?
No, had to make it special, maybe in the metal shop. So how about to contain 1 mole of raindrops? I'll tell you this: that it's going to be a 30 diameter tank. 30 meter diameter is probably from here to halfway into the lab. How high would it have to be? 3 miles,
A raindrop?
mole of raindrops.
Every raindrop.
All of them. Mole of them. All 6.02 times 10 to the 23rd. It would be a distance, so if it's 30 meter, 280 times higher the distance from the Earth to the Sun. That's how high would have to
So
be.
we actually figured this out.
We can figure it out if you get the volume of the raindrop and then how much area it would take and how much volume it would take. You can figure it out in probably 30 seconds. How about to contain 1 mole of water molecules?
Right here.
Right there? How much is 1 mole of water molecules? 6.02 times 10 to the 23rd water molecules. Let's do this. What is water? Formula? H2O. You can get the molar mass. What's the molar mass of hydrogen? Periodic table says 1.00794 times 2 plus 1 oxygen times 16. That comes out to about 2 times 1 is 2 plus 16 is 18 grams per mole. So if you wanted 1 mole of water molecules, how many grams would you need? 18 grams. 1 milliliter of water equals 1 gram. So you'd have to measure out how many milliliters. 18. It'd be about 18 milliliters of water. So this is 1 mole of water molecules right there. So it's a tiny amount of water, but a huge number of water molecules. So it's sitting there. Okay. So why such big number? Because the atom again is so what? Small. Okay. So that is it for today.